Thank you very much for joining me for a lovely, I guess, really foggy Thursday morning. My name is Il-Sung Lee. I'm a product manager with the Google Cloud. I'm actually based in New York, so I had to fly out here. And thank you for coming, for joining us to talk about the new crypto key and storage options for the Google Cloud Platform. I just want to ask people here, so how many people here care about crypto? Okay, so you guys are all in the right room, so that's fantastic. That's a great start. What I'd like to talk about in this talk right now is that I'd like to start talking about the new key storage options that we're going to provide with the Google Cloud Platform. Now, how many people think they know what the new key storage option is going to be? Like, anyone have a guess? Okay, someone say HSM. So you guys were listening, so fantastic. I want to tell you, this is really, really thrilling for me to be up here, to be able to talk about this. You know, for so long, I've had to actually not talk about this and tell people I work on something that I can't tell you about, including my wife. And then my wife would keep asking. I tell her that I can't tell you. And now I can tell her, and she's like, I don't understand. And so hopefully you guys can understand a little bit more better than my wife can. So that'd be fantastic. I'll also talk about some new key types and capabilities that we can do. And then we'll just start generally discussing things around how to help satisfy your compliance requirements, what we're talking about, and how to help meet internal security requirements. All right, does that sound good? All right, cool. So let us start off with kind of an overview. We always do these overviews, and I promise to make this as least painful as possible. But if you've ever talked to me before, and did I mention this? Yes, I did. I work in New York. I'm the product manager for a lot of key management in the cloud. And so I've talked to probably some of you, at least, and discussed some of the current key management options. So if you take a look at this scale, you have that scale of control over keys. And on the far right side, you have no real control. And on the far left side, Google really has no real control over the keys. So on the far right, or left side, the default encryption. That's the thing where we provide you with encryption of your data at rest, whether you want it or not. Now, we're a little bit, like authoritarian in that way, but you guys don't have a choice. When you put the data up into our cloud, it has to be encrypted. We don't really allow you not to encrypt it. And so what happens is that you put your data up to the cloud. We have this elaborate system by which we break up your data. We shard it or break into chunks. And then we individually create random encryption keys for each single one. And those encryption keys get regenerated every time you update that data, and they get sprayed out to the data center. So if you attended the talk that Maya and I did yesterday, we talked a little bit more about this. So I won't go too much into it. But the keys that protect each of those chunks is protected through a key that's in our internal KMS system, that's protected through an elaborate key system. And I think the thing I said yesterday was that ultimately that key actually gets stored in physical media in case of a complete global disaster, and it's known by 20 or less people in Google, I believe. And I'm not one of them, so if you try to come and extort me, then I know nothing. Now, the next thing on that list is that if you want to go a little bit more into control, we have Cloud KMS. And this is where it's basically an external instantiation of our KMS system. So we're now providing you with the capabilities of actually creating an AES-256 symmetric key to do encryption of the data, right? I mean, you can do creation, deletion, rotation, all the things you expect to do. In addition to that, we've been integrating this with various different services, our so-called customer managed encryption keys. And then next to that, we have the customer supplied encryption keys if you really want to have more control over your keys. And in that feature, we actually don't keep your keys at all. So when you actually put data up in your GCS bucket, for example, then you need to provide a secret that we use to help encrypt the data. And then every time you want to access that data, you have to re-provide it. And we use that secret to help decrypt the data, and then we get rid of it. It never gets stored anywhere. It definitely doesn't go into disk. It's only in memory. So it's something that's available for GCS and GCE, but not for other services. One of the main problems is that when we say we don't keep the key, we really don't keep the key, right? And so if you lose a key, there's absolutely nothing we can do about it. And if you don't provide the key, there's really nothing we can do about your data. So for services that require us to do background operations, such as like compaction, for example, which some of the services do, we can't help you because those things are going to fail. We don't have the key to do that. So as a result, it's only available for GCE and GCS and will likely not go beyond that. Then finally, on the far right side, and this is something that some people have done. I see some people here who might have done this. But basically, this is where you want to keep your own keys in your own device that you want to have complete control over and insurance and everything else. And so you will provide the HSM, and we'll help you host it somewhere close to one of our data centers. Okay, and we can help set up the high-speed interconnect, provide a super low latency connection to us. Obviously, the downside to this is that you are still responsible for doing, buying the devices. You have to still operate them. Okay, you have to make sure that they're all clusterized, everything else, and that your application will basically connect directly to it, right? So you're not really leveraging any cloud services directly for this. All right. Oh, and feel free to ask any questions as I go along the way. And if you feel like using the mic, go ahead. Otherwise, just shout it out. So now I'd like to introduce Cloud HSM. The thing that my wife doesn't really understand, but I tried. So this kind of fits right in the middle of the scale, right? So it gives you a little bit more control over keys or KMS in the sense that you now have a service where it's protected by a hardware security module. How many people here know what an HSM is? Wow, you guys are awesome. Yeah, so they give you the assurances of what an HSM provides, right? So we can't get the key material, things like that tightly bound to the hardware, and it basically gives you more options now for your KMS. And so let's start off with, it sounds like most of you guys know about this, but just kind of indulge me, and I'll just try to make sure everyone's kind of a level set, and explain what an HSM is. So an HSM is a hardware security module, right? So it basically is a physical device for managing keys and performing crypto operations. It does a little bit more than that, but essentially that's what it's really used for. And people like these things largely because they can create keys that are non-exportable. The hardware will provide some guarantees that once you create the key inside this thing, it's not exportable, kind of, right? I mean, the vendors like to allow the keys to move around between their own devices, but you can't export it to anything else. And then they're often provide tamper evidence and tamper resistance. So if you try to break into one of these things, then they're saying that they'll probably be able to notice and they'll record it. And if you actually try to compromise it and you get close, then it'll do things like zero out the keys, so the keys are completely wiped from the system, right? And the other thing is that they come with a FIPS 140-2 certification. And yeah, please.
Not 3 if it's a hardware device.
Sorry?
You haven't achieved FIPS level 3 yet if you're doing penetration?
Well, the FIPS level 3, FIPS 140-level 3 dictates some other conditions around what you have to provide and such. HSMs typically provide level 2 or level 3, right? Yeah. And I'll talk a little bit more about this as well for our service. But this certification is important. It's a certification that comes out by NIST, in the U.S. government. It's the only real good certification that's available for crypto modules, and that's what it defines. So as a result, a lot of people depend upon using FIPS as a kind of gauge to whether this is adequately implemented or not, right? And so again, like you asked, for level 1, you can do this with software. Typically, for anything greater than that, you need a hardware module like an HSM. Now, in terms of main use cases, a lot of people use this for regulatory compliance, right? So if you're doing things like you're in the financial industry, maybe the healthcare, you do some payments, things like that, you likely do require to have something that actually has some high bar around protection of keys. Maybe you have specific NIST FIPS requirements, then these HSMs become extremely valuable. And the other thing is that whether it's right or wrong, people feel more safe with putting their keys in hardware devices because of some of the properties I listed before. And so if you have high value keys, for example, like perhaps the keys for your top signing cert, then you may want to put into an HSM just to make sure that you have that extra assurance that they're protected. Okay, makes sense? You guys now know as much as I do about HSMs, so that's great. Now, what's Cloud HSM? So Cloud HSM is basically taking the HSMs and making it into a managed service, right? And when I say managed, I like to kind of clarify what Google's definition of managed is. So managed means that basically we do everything for you. The only thing you have to worry about is the API, right? Just to, if we're doing the logical application level of API interaction. So when we manage it, it means that you don't have to worry about any of the hardware or the infrastructure or anything else like that at all. Okay, we'll make sure that the patching of the hardware is all done by us. If there's any kind of availability concerns, we've fully clusterized everything. We have a very smart layer that actually makes sure that it's completely available. If there's scaling issues, we auto scale. We just basically restart. That was really interesting. Sorry. Yeah, we basically are able to scale pretty much horizontally with any kind of workload that you bring along, right? So there's no concerns around that. And they're also rooted in physical HSMs, so the key material is not available outside the HSMs, which means that you can't get access to the key material, but neither can we. Okay. And if you take a look at that diagram there, the way that you think about this is that the Cloud HSM feature actually leverages the exact same API front end as Cloud KMS. So if you're familiar with Cloud KMS, and I'll show you in a demo later on, it's actually as simple as just flipping a flag when you create the key. And all of a sudden, everything else that you have in terms of the APIs you use, the client libraries, this works, right? Except that the keys are in HSM. And I'll also explain to you in a demo about how we actually prove to you that the keys are actually in the physical device. Okay. So in the diagram here, going back to that, when a request comes in from a client, they go to the KMS service. And the KMS service knows that this key is a software key, so we go down to the software key backend, and we do the operations there. Or if it's a hardware key, then all the requests get routed to the hardware layer, which actually goes to the individual hardware node. We obviously do some smart logic there in terms of picking the right node. And in that case, all the crypto operations and all the key creations and everything else actually happen right in the hardware. Okay, it's not that we're doing the software. These things actually happen in the software. I mean the hardware. Now, why should you use Cloud HSM? Again, I'll say this a lot because this is what a lot of customers care about. But compliance comes up very, very, very often, right? So if you have a compliance need, whether you want it or not, it's going to come up again. Now, regionalization is another really, really cool feature that we provide as part of the new product. So if you create a key within a Cloud HSM, then that key is actually cryptographically bound to the hardware devices within that region. Okay, so suppose I go and create a key in US Central 1. Those hardware devices in US Central 1 are the only ones that are able to use that crypto key. Okay, and so the way that we have things architected right now is that the keys are always stored in one of our highly available file systems, and those things can actually move the keys around. And in fact, we don't provide any guarantees around the location of those stored keys, but the keys themselves are protected by the HSM, or at least the HSM keys. So they can only be used, unwrapped and used by those HSMs. HSMs in a different region cannot use them. Okay. We will, right now, the Cloud HSM feature is currently in alpha, soon to go into beta. And right now we're looking at US Central 1, but we will be releasing the beta across the United States and then slowly start rolling out globally. So this is something that you should be able to see around the world. Yes, please.
You mentioned that the HSM, Cloud HSM keys are regional. What about the regular KMS? Are those also region specific or are they available across?
The question is whether the same regionalization guarantees happen with KMS keys, regular KMS keys. The answer is no, right? So the Cloud KMS keys, when you actually create the keys in a certain region, they'll be very likely served from that region. But the system, in order to provide availability or suppose that a certain region goes down, it is able to serve that key from different regions if necessary. Yes, please.
So that means that, I think you mentioned it, but I would want to clarify, is that with Cloud HSM, you do not get high availability across regions.
Yeah, so the question is does that mean that with Cloud HSM we don't get availability across regions? That's actually my next bullet. So right now we're in one region because we're in the alpha, and then beta will come up with more regions, but we will actually provide support for multi-regions, right? So this means that just like Cloud KMS right now, we'll have a global region, and we will have a US region, a Europe region, and an Asia region. And what these multi-regions mean is that when you create a key within, for example, the US region, then that key can actually be served out of any of the HSMs within those multiple regions. Okay, so it's up to you. You can actually choose how granular you want this. Over there, please. Oh, sure. So, I'm sorry. So the question is, can we explain the context of alpha? So alpha for us is generally, not always, but a closed release, right? So we have a subset of people who are actually using it. They're testing it, providing some, close interactive feedback. And then when we get to beta, beta is the point at which we actually release it publicly, where we will provide, full support for the product. We'll provide, you can actually put production workloads and everything on it. The one thing that we don't necessarily provide until we go generally available is the SLA. Yes? The question is whether anything that, if the features that we're mentioning right now would be cut from the beta. No. No, the answer is no. Everything that I'm talking about here is definitely stuff that we'll be providing in the beta. Question?
HSM will be globally available?
So yeah, the question is when will HSMs be globally available? I can't answer that right now because it depends upon schedule around when we can actually start deploying the hardware to other things. The Cloud HSM has been a very interesting project, at least for my career, because it's not only software, but there's a strong hardware component to it, right? And so especially since we're dealing with cryptographic devices as well, there's some increased sensitivity. So what we will do is that we will actually start rolling these things out depending upon what our hardware operation schedule and everything else is. And we'll have to figure this out, but I don't have that answer right now. Yes?
Is the Cloud HSM and HSM a partition or a shared partition?
That's a good question. So the question is whether the Cloud HSM is a partition or a shared partition. We don't follow the traditional model that you may be used to from using a regular HSM. We're not providing you with a dedicated partition. Basically, it's a multi-tenant service, right? So the only tenant for these HSMs is Google, and we will manage the separation of your keys and everything else for you, right? And this is a little bit of a difference from the way that things happen from your original traditional model. But what this allows us to do is that allows us to develop extremely flexible and scalable type of service, right? That allows us to provide this fully managed type of features that we hope that you'll enjoy. All right. Next slide. So now I want to talk a little bit about the key features. So three things I want to point out specifically. I want to talk a little bit about asymmetric keys, and I think pretty much everyone here should understand what that is. Statement attestation, right? This is basically the validation that you have a key in the HSM. And then CMEK, or customer managed encryption key integration. Okay, and let me talk about each one of these individually. So asymmetric keys. Up till now, KMS has only provided support for symmetric keys. So you had one choice. You can do AS256 to encrypt data, do envelope encryption, or do encryption with other services. But that doesn't cover all use cases necessarily. And so now we're going to allow you to actually create different types of asymmetric keys and support things like code signing. This comes up every so often. People want to sign certain things, and they want to make sure that the signing keys reside in the HSM itself, right? It's very, very typical, and it makes a lot of sense. And certificate authorities as well. I mean, if you work for an enterprise, then chances are that, for example, you have internal non-authoritative CAs, and they're probably doing things like dishing out X509 certificates to all your laptops and everything else that happens in your enterprise. And so that's something where you can actually take those valuable keys, or the root keys, and stick them into our Cloud HSM. Now, we are providing different types of keys and key sizes for signature verification. So as you can see there, we provide RSA 2K, 3K, and 4K keys. In addition, we support a couple of elliptic curve with two different types of NIST curves, so P256 and P384. Now, for decryption purposes, you can actually use RSA keys for decryption. So if you choose to actually decide that I want to do some kind of PKI type environment, then that's available for you as well. And I want to put out, there's a box right on the bottom right corner, that this is also available for Cloud KMS in the software. So everything that I've discussed here in terms of asymmetric keys, you're free to do this as well in the software if you choose to just use something that's more globally distributed and cheaper and faster. Okay, any questions about that? All right, cool. Now, statement attestation. This is where we provide you with the confidence that your keys were actually created in the HSM itself, right? Not that, we could always say that, yes, please trust us, but we thought that you guys might feel a little bit better about being able to trust something more than this, or my word for it, standing up here on this pedestal. So what the statement attestation is that it's a cryptographically signed statement from the actual HSM hardware, and we're not using any kind of Google developed or own, branded hardware. We're actually using third-party hardware that's created by a third-party manufacturer. And so the device itself will provide you with a cryptographically signed statement that says that this key was actually created within our hardware boundary, within the FIPS boundary, okay, which is probably something important. Yes?
Can you share who that third-party HSM is?
The question is, can we share who that third-party HSM manufacturer is? It's Cavium. Cavium? There's no point in trying to not say it, because when you actually look at the attestation statement, you're going to see the signature, and you're going to see that it's not a Google signature, right? Now, the signature can actually be, I'm really sorry, I'm not sure. I'll tell you what it is. I'm doing demo on this laptop later, and they told me that in order to keep the screen from locking, that I should play YouTube in the background. So I have Schubert running in the background, in case you're wondering what that was. Okay. Well, the talk's not going that badly yet, so we'll see. So that statement attestation can be verified manually. Okay, the manufacturer will publish the format of what the attestation statement looks like, and we will provide scripts that you can download. They'll just be Python scripts. Fully you can take a look at it and make sure it doesn't just say printf, everything's okay, right? So you can download those, and you can use this to actually verify key attributes. And speaking of that, I'm going to go and give you a demo of this right now, where I'll show you how to go and create an asymmetric key and verify that it actually was an asymmetric key in the HSM. So if you wouldn't mind switching to my laptop. Okay, so can you guys see this, or is this too small? Is that better? Yeah. I wish there was a quick option for Magoo, but you know what? Let me just do it this way. So is that better for everyone? Can you guys kind of see? All right. So I created a key ring. I already did this because I didn't want to step through everything in its gory details. But I created a key ring US Central 1, which is where our current alpha HSMs are staged. And so this is actually, one other preface is that this is the alpha UI. The beta UI is very, very similar, but it's a little bit different. But it's not going to be marginally different that you're going to be confused. So I'm going to create the key. And you'll notice right away, if you're familiar with Cloud KMS already, that things are a little bit different now, right? So I'll create a key that says, like HSM demo key 1, okay? And I now have the choice of actually choosing different types of key purposes. So I can choose a symmetric key, which is a default, or I could create an asymmetric key for our RSA asymmetric key for signing, or I can create an RSA asymmetric key for decryption, so encryption, decryption, or an EC key. So let's create an RSA key, and then it gives you the option to choose different types. There's a bug in the UI. There should also be a 3K key listed there as well, but you can choose 2K, 4K. And then you have one other option, which is a protection level. This is a key. This is where you can actually say that I want to go and create the HSM key. And so that's all you have to do. Yes, question?
Just a quick question.
Yeah, please.
With respect to cost that you had up there, 6 cents a month, based on storage construct that you guys execute, you shard the data out. It's assumed that we're going to use the same key across the shards, right? Or not?
It depends. It depends.
If not, are we getting charged $6 cents a month?
No, this is on a per key basis, right? So if you choose to, and I'll show you a demo of this later, but when you actually associate the key with, for example, a GCS bucket, then regardless of how many buckets you protect with it, it's charged on a per key basis.
I'll get with you.
Sure, no problem. All right, so I chose protection level HSM, and then I created, right? And I've already created a ton of these keys, so that's why it's kind of busy over here. But you can see here that, which one was the one I created? Yeah, HSM demo key, right? And demo key 1 there. So you can see right there that it actually create the key And it says that's asymmetric key using RSA signing. If you click into this, it comes up with the key versions enabled. Now, one other thing I want to point out here is that if you look down at the bottom, you'll see that there's a couple more options now. So, oh, you can't really see it, I'm sorry. But there's a get public key option, and right beneath that, if you can get past the letters overhead, it actually says get attestation. So that's where you can download the attestation statement. And you can also do this through the G Cloud command. So let me just do it through G Cloud, and I'll show you a quick demo after this thing connects. Okay. So what I'm going to show you is I'm going to show you a script that's going to kind of walk through this. Rather than see you guys type on stage and make mistakes, I want to show you through a script how things work essentially. And I'll walk you through doing a signing operation, plus I'll show you how to actually validate the attestation. Okay? So if you look here, so now what we're going to do is we are going to create, we're going to go create a EC384 key. And so you can see that right here, right? That's one of the options. And it's got a purpose of EC signatures, right? And so that's going to get created. Okay, so the next thing we're going to do is we're going to retrieve the public key. Okay, so simple thing to do. And also, the other thing I should mention is that when we create the key, we actually request the attestation file. That's what the -- attestation file is. And then the next thing is that we actually just request a public key. And so that's going to download that as well. Right? And there's a public key. It's base 64 encoded. Right? So the next thing we do is we just create some dummy data. Right? So foo and some file. And what we're going to do now is that we're going to go and call the HSM to actually go and sign the key, right? No, I'm sorry, sign the data. And so in this case, we're using the EC key that we just created and passing it the data. Now it's going to come back with a JSON file, and the JSON file, provides one of the fields called signature. So this right here is the base 64 encoded signature. Now, my apologies to people in the back, but you don't really need to see what the actual values are, obviously, right? It's just base 64 encoded of a signature. And so right now, the next thing I'm going to do is that I'm going to actually extract that, put that signature into a file, and then I'm going to use OpenSSL, right? So the OpenSSL is now running locally, and it's going to verify that that signature corresponds to the data that we just signed, right? And hopefully it says verified OK. It says verified OK. So the signature that we generate with HSM, Cloud HSM, corresponds to what OpenSSL just verified. Now that we've done that, let's just say that we want to make sure that we're actually using the proper key in the HSM, and we want to make sure that it's not some software key. So we have that attestation file that we just downloaded, right? And what this Python script that you can download off the web does is that it actually takes this set of certs, this cert bundle, and actually verifies that the signature associated with the attestation statement corresponds with what the certs in the cert bundle. Kind of make sense? Okay. And, oh, sorry. I have to, I didn't install the Python handler for OpenSSL. But we'll skip that for now, but essentially what that comes back with is says it's verified, okay? And then the next thing we have is that we can actually query the different attributes within the attestation statement. And so if you look through it, and I just want to point out a few things, is that there's a lot of things here. Oh, geez, I hope you guys can see. There you go. Okay. There's a few things I want to kind of point out here. One is that if you look at this, there's an ID field here. This ID field is basically a concatenation of a random string plus the SHA hash of the actual key ID, right? So you can verify that by matching the two together, and actually the script will help you do that. And then there's an EKCV. That's a public key. That's a hash, the SHA-256 of the public key itself. So you've already downloaded the public key. You can verify the hash against what the HSM is reporting, and this gives you a nice cryptographically strong way of actually validating that they correspond with each other, right? And this is something you can obviously do only for asymmetric keys. One other thing I want to point out here is that if you look in the private key attestation statement section, there is a field called extractable, right there, and it's set to 0. And what that's saying is that the HSM is confirming that the key is non-exportable. So we now have proof directly from the hardware that the key that you're trying to refer to is actually not extractable as well. No, yeah, please.
If we don't get this attestation statement, is it in the log files, the HSM?
The actual, which one? The attestation statement? Because you can download the attestation statement anytime you like.
Okay.
Yeah, you don't have to do it right at key creation. The other thing is that you can also use this to actually help validate that the resource name matches what was reported in the attestation statement. And the Python script here helps you do this. And so it verified here that the keys match in attestation. And then the other thing it'll do is that it'll match that the public key that you've downloaded matches the hash that's in the attestation statement as well, right? And so you can do that as well, and it comes back and it says that it matched. Okay. So this is a really, really cool way of actually, especially if you're a crypto nerd, to be really secure and really, really feel comfortable with the fact that I am actually talking to the hardware device. I'm using a key that I think I'm using. All right. Yeah, question.
Will there be eventual integration with like UV keys or any like hardware-based keys connecting to the cloud, like for any type of personal key management?
So the question is whether there'll be any kind of integration with YubiKeys or any kind of personal integration with Cloud HSM. If you're talking about doing things like being able to like bring your keys up and store them into the HSM and such, then that is something that we're strongly looking at. We don't have anything available right now, but if this is something that's interesting to you, please come up later and we can chat a little bit more. Yes. The question is whether this will be supported on a mobile device. This is a cloud service, so as long as you can access it through the internet, you can access it anytime you like. Well, the question is, because this is HSM, whether we need a physical connection. No, the whole point of the Cloud HSM is that we're providing a cloud feature. So we're backing it using hardware devices that we're putting into our data center, but we're exposing it as a cloud service. So basically, it's a web endpoint for you. Okay, question? The question is, can you use the same RSA key for both encryption and signing? No, you can't. The way that it's set up is that you need to actually state the intention of the key when you initially create it. Right. So the comment is that you can usually use the same key for example, email for doing both signing and encryption. That is true. The way that we've designed this right now is that we want to make an explicit intention around what the keys are used for, so that we can actually limit the scope of what the keys can do. If there's a reason that you think that we should be able to support both with the same key, then I'm very happy to hear this, and we can talk about this in the future. Yeah. Thank you. Yeah, please. So the question is whether the asymmetric software keys are GA or, if they're out or what's the status. Currently right now, they are in the same situation as Cloud HSM. They're in alpha. And so when Cloud HSM becomes available in beta and becomes public, you can expect to see the asymmetric keys being available in software as well. Okay. All right. So that was a demo actually for just showing you attestations and making sure that we can actually prove this. Is there any questions around the demo? All right. Can we switch back to the slides, please? Thank you. Yes, please. I'm sorry, is the tool, is it a paid service? Do you mean the Python scripts? So the Python scripts that we use to actually verify it, it's not going to be a paid tool. It's going to be something that we're going to allow you to freely download. And it'll be something that will be published on the web where there'll be a link for you to download. Yeah, so the question is whether the actual process of generating key and verifying is a paid service. Yes, so Cloud HSM will be a paid service just like Cloud KMS is. So you'll be charged to do the signing operation, but the verification operation that I showed you was actually done on local client using OpenSSL. So that's something that you would do on your side. Okay. We've not yet heard anyone who had a valid reason for doing verification on the HSM itself, but it didn't quite make sense to us. But if there is, I'd love to hear it because it eluded us so far. Not even in FedRAMP environments, that's true, because typically you don't have the signature verifications happen outside. The signing operation is the thing that's really, really important. Yes?
So where do you kind of envision this product to be both for personal users and for enterprise users?
The question is whether I envision this for enterprise and personal.
But where? Like, where do you kind of see, like, maybe like a personal user might use Google HSM?
Oh, I see. So the question is where I would envision someone who uses it for personal use, perhaps. I gotta be quite honest. I haven't heard of a lot of people who really feel like using HSMs for personal use, right? There's typically not anyone who has a personal reason to have something that's very, very secure like this. Now, that being said, this is a managed API. It's on a per usage basis. So if all you're doing is using, like creating a single key and doing a few operations, it's not going to cost very much at all, right? And so you're perfectly welcome to do that. But I've only met one person I know that plays with HSMs for fun. It's one of our PMs. He works out of Kirkland, and he likes to buy them off eBay and has a whole garage full of them. And I don't know. I don't think there's something right in his head, but I think that because no one does that for fun, right? But I envision that this will be very popular with a lot of enterprise users. For personal users, I can see it if you need to do something like you want to host your certs, for example, and you need to actually you just want to make sure that's in something you feel a little bit more secure about because it's up in the cloud. But it's it's totally up to you. Yes. Yeah, the question is whether this will be available for marketplace integrations. No, not the way that is right now. But anything is possible in the future. Yes, question.
Will it be available for a separate instance of HSM, or will it be a multi-tenant offering?
Oh, the question is whether this will always be multi-tenant or it can be. Yeah, right now this is envisioned to be purely a multi-tenant service. The reason is that in order for us to provide the amount of scale and flexibility that we have and kind of design it to be basically exposed as an API service, it was necessary to make a multi-tenant and also economies of scale and all the other great reasons people use the cloud. But yeah, that's a great question. It's multi-tenant. Yes.
Firstly, are HSMs going to be available in all regions? And secondly, are you working on any kind of integration with HashiCorp?
Yeah, so the first question is, will the HSMs be available in all regions? The HSMs will be available globally, and it may or may not be available in all regions, right? And so, as I said before, it's not as easy as deploying code and pushing out software because there's a lot more process involved in trying to get devices put into the data center. But we will make sure that's represented in the places where it's most valuable to people. And so, if there's a particular area that you guys care about a lot, then I encourage you to come and talk to me afterwards, and we can chat more about this. And then the second question was whether this can be integrated with HashiCorp Vault, right? It already can. It already is, because essentially HashiCorp Vault is already integrated with our Cloud KMS. And as you just saw, the only difference between Cloud KMS and Cloud HSM is a flag when you actually create the key. So to HashiCorp Vault, it looks like just like a regular KMS key. All right. So the final thing I want to talk about is the CMEK integration, or customer managed encryption keys. So this, I think, is a really, really great feature because a lot of people have put data into the cloud, right? And they want to make sure that they have some control over those cloud services. And right now, what you can do is that you can actually put data in BigQuery, for example, which is already GA, and you'll be able to actually associate the encryption key that ultimately protects the data in Cloud KMS, and consequently, since Cloud KMS is integrated with Cloud HSM, in a Cloud HSM key. And it's available for not only for BigQuery, but also for Compute Engine, which is in beta, also for cloud storage and Dataproc. Okay, and so what I'd like to do now is I'd like to actually show you a quick demo of how this works and how simple it is. And so if you've already used custom managed encryption keys already, then this is probably something that you've already gone through. But I think it's kind of neat to actually realize that everything is being protected ultimately by a key in the HSM. If you can switch over, please. Okay, so what we're going to do is we're going to first start off back in the KMS console. And remember that when we actually use customer managed encryption keys, we're talking about symmetric keys. So let's go and create a symmetric key here. Let's just call it, HSM demo, demo sim key. Okay, and it's going to be a symmetric key, and we'll put it in hardware, because that's what you guys are all here to look at. And I'm going to create it. Okay, so HSM, I apologize for all the keys, but so here's a key that we just created, right? And I'm just going to go through, and I'm going to, well, I guess I don't need to do this, but I'll do it anyways. So what I'll do is that I will now go to create a new bucket in GCS, and I'll just say that this is a HSM demo bucket, bucket 2. So I might have already created bucket 1. Acquire regional, US Central. And here's the thing, in advanced settings, you can actually go right from the UI and choose to say that I want this to be managed by Google, which is the default encryption, or you can choose to say that I want to use custom managed encryption keys. And remember, it doesn't care whether it's a KMS key or an HSM key, right? And so all you have to do is say custom managed key. I'm going to select the key, and just to be faster, I'm going to type in the actual key name, right? I do that, and it's nice enough to actually tell you that in order for this to work, the service account associated with your instance of GCS needs access to that key, right? And it'll actually do that for you. So I'm going to hit grant. Okay. And so now I have created this bucket. Whoops. Did I miss? Oh, I've already got 2. Oh, you're right. You're right. Oh, this always bugs me about this. I should go and talk to them. There you go. Yeah. So I'm just going to upload a file. It's going to be a stupid file, like sample text. I think that, if I recall, this file, all it says is that this is data. Let's see. There we go. Test data for bucket, right? So now what I'm going to do is I'm going to actually go to KMS now, and this key that we just created, this HSM demo sim key, I'm going to go there, and you can see that, I'm going to go to the key itself, and you can see on the side here that it lists the permissions, and sure enough, you can see the fact that, the service account for GCS was already added there, and that was done automatically. So I'm just going to copy this just so that I can add it later, and I'm going to delete it, right? And so I have now effectively deleted this access. So what happens now? So what happens is that now when I go back to GCS and I try to go and read any of the data in that bucket, right? First of all, GCS does its own permission check and says, yeah, you guys are good. Now let me figure out which data encryption keys I need to decrypt, and it's going to send that over to KMS. And then KMS is going to go and see those keys and say that, okay, let me see if you're allowed to decrypt this. And it's going to see that you're not allowed to do this, and it's going to give you access denied. Or at least that's what we hope will happen. It usually takes around a minute or so for the changes to propagate. So we might have to try this a couple of times. So let's see if it works right now. Yeah, it works. So we'll give it a few more seconds. And
Quick question. So you just created a deck. Is there a KEK deck model for this that a customer can manage only the KEK?
so the question was, I just created a deck. Is there a deck KEK model? I actually didn't create a deck. I actually created a KEK. So it's a data encryption key. It's the keys that actually encrypt the base data. And then above that, the second level key is a key encryption key. When you talk about customer managed encryption keys, you're always talking about that second level key encryption key, right? And so what happens is that in a normal case, in GCS bucket, you have the bucket encrypted with its local keys, and then it goes up to the internal KMS. In the CMEK model, that goes to Cloud KMS instead. So when you need to decrypt those keys, it actually goes and contacts Cloud KMS and says, can you please use this specified key to encrypt my data encryption keys?
So you just link the CAC to that bucket?
Correct. Correct. So now, if I do this, I think it's enough time. You get the permission denied on Cloud KMS key. It's really small, I'm sorry, but that's what it says up there, and people in the front can attest to it as well, right? Now, basically, I just proved that it works the way it does, right? You now can use your keys to actually have some granularity around control of your data. So now if you go back to Cloud KMS and decide that we're going to re-add the permission, and we'll give it back the encryptor-decryptor role, right, and add that. Okay. Then we expect to see that, this is going to work again, right? And sure enough, it works again. So it's as simple as that, right? So, this is not really anything new if you've been using customer managed encryption keys, but it's just a quick way of showing you that really nothing changes. You've just been able to use an HSM key to secure your data out in GCS. And I'm looking at the time right now, so we're running out. I was going to do the same thing with BigQuery, but it's essentially the same thing as well. Okay, you can actually just use BigQuery associated with the HSM key, and then remove permissions, and all of a sudden things start to break. Okay, so going back to the slides. Now to summarize, what we've learned today is that you can actually use some of the things that we provided now to help meet your compliance objectives. Previously, before, if you came to us and said, do you have anything that can help me satisfy the requirements for a FIPS 140-2 level 3 device or 3 crypto manager, then we didn't have an answer, but we now can actually tell you, please use Cloud HSM. The devices are all FIPS validated. Okay. You can meet your security requirements around the keys. If you have more strict requirements around saying that I want to make sure that there's extra security around some of the keys that I put in the cloud, there's an option for you. And also, because it's a fully managed service, and I like to stress this, you don't have to worry about anything around your key management. You only have to worry about your key management, not around your HSM management. Okay. And finally, you can now actually go and use it for a lot more things. You have that CA that you want to move up to the cloud because you want to close your workload. Now you can do it, right? So it's all possible for you. And with that, I think we're done. We have a couple minutes, but I'd like to thank everyone. And if you have any questions, please let me know. Yes? Yeah, good question. So the question is whether we're considering any use with encryption transit certificates and such. So right now, we don't have something like that. That is an area that we're interested in, but the answer is right now, none. Any other questions? Yes?
Maybe some idea. You said that right now it's alpha, it's going to be beta, but maybe some idea within 95 percentile or some time frame around it.
Yeah, that's a tricky question. So the question is some 95 percentile time frame by which it move to beta. Yeah, I'd love to tell you, but unfortunately, I'm only allowed to say it's coming soon. And so I'll just say coming soon. Yeah, I'm sorry. Yeah, it's. All I'll say is keep watching our Google blog, or the GCP blog, and just keep monitoring it. Hopefully, you'll be pleasantly surprised sometime soon. Yes.
Last question.
Yeah, please.
Can you set an account flag variable that will only allow HSM keys as opposed to KMS keys?
Good question. So can you set some kind of variable that only permits you to create HSM keys? You will be able to do this through IAM conditions, right? So you can set a condition that only authorizes you to actually create keys with certain flags, right? So this will be something that you'll be able to implement. All right? Great. Well, thank you very much, everyone.